Let's try this next example. It's got 3 variables. So I'm going to leave myself a bit more room than I did last time. My augmented matrix is going to have 3 rows and 4 columns. First equation goes 2x, 1y, negative 1z, and the value is 2. Second equation says 1x minus 2y plus 3z is 7. And the third equation says 3x plus 5y minus z is equal to 0. Okay, what do I have to do? Step 1, choose a pivot. I could use this one, but then I might end up with some fractions later. If I choose this one as my pivot, I've already got a 1. So this is what I meant in my notes where I said it doesn't matter what you choose, but it might make your arithmetic easier. So I'm going to choose this as my pivot. Step 2, swap that to the first row. So I'm going to swap rows 1 and 2. And I'm going to get 1, negative 2, 3, 7. That was my second row. Then my first row. 2, 1, negative 1, 2. I haven't changed any information. I've just exchanged 2 of the equations in the order I wrote them. Don't forget the last row, negative 1, 0. I have a pivot. Step 3, eliminate all the entries below the pivot. So in my new matrix, row 1 isn't going to change. 1, negative 2, 3, 7. Row 2 is going to become row 2 minus 2 row 1, because that will eliminate this one here. Let's have a look. 2 minus 2 times 1 is 0. That's what I wanted. 1 minus 2 times negative 2. Well, that's 1 plus 4 is 5. Negative 1 minus 2 times 3. Negative 1 minus 6 is negative 7. 2 minus 2 times 7. 2 minus 14 is negative 12. And in the same step, I can eliminate this one. Row 3 is going to become row 3 minus 3 lots of row 1. Same reason. 3 minus 3 times 1 is 0. That's what I wanted. 5 minus 3 times negative 2 is 5 plus 6. I think I did something wrong before. I'll check it in a minute. 5 plus 6 is 11. Negative 1 minus 3 times 3 is negative 1 minus 9, which is negative 10. And 0 minus 3 times 7 is negative 21. What I wasn't sure about was whether I got this number right. Let me check. It should be row 2 minus 2 lots of row 1. 1 plus 4 is 5. No, I did get it correct. Okay, I have successfully eliminated all the entries below the pivot. Step 4, repeat. I'm now looking only at this section. The rest of my matrix isn't, well, actually here. The top row and left column are not going to change. So, one of these has to become my pivot. There's no clear preference here, so I may as well just use the one that's already there. So, that's my pivot. It's already on the top row of that subsection I'm looking at. 1, negative 2, 3, 7. 0, leave that row alone, negative 7, negative 12, and eliminate this 11. How do I eliminate 11? Well, I'm going to have to get rid of this. I'm going to have to use this. I don't really want to use this because there's a 1 here. I have to use this row here. It's going to be a nasty fraction. I have to start with row 3 and I have to take away 11 on 5 times row 2. This one will stay the same. They're both 0. 11 minus 11 on 5 times 5 is going to become 0. That's what I wanted. Negative 10 minus 7 times 11 on 5. If you're not sure, let's go over here. Negative 7 times 11 on 5 is negative 77 on 5. And I'm going to take that away from negative 10. Do you know what? I'm going to use a calculator to make sure I don't make a silly mistake. So what was I doing? Row 3, negative 10, take away 11 on 5 times negative 7. 27 on 5. And the last one, I'm going to do the same thing so I avoid silly mistakes. What am I doing? I am going to go row 3, negative 21, minus 11 on 5 times negative 12. 27 on 5. Well, that was nice, wasn't it? Oops. Okay, I now have row echelon form. All the numbers to the bottom left of the diagonal are 0. To solve these equations, I'm going to make it into reduced row echelon form by making all the entries above the diagonal 0 and all the diagonal entries 1. Let's start with that third row. This is easy. This tells me that z is equal to 1. I just have to multiply by 5 on 27. Okay, so let's simplify our z. Here we go. I'm going to multiply this by 5 on 27. 1, negative 2, 3. The top two rows are not going to change. 0, 5, negative 7, negative, 12. So the bottom row is going to become the inverse of this. 5 over 27 times row 3, which is going to make this 1 and this 1. Okay. Now, just going to move that up a bit. All right. I now have a 1 here. What I then have to do is eliminate all the values above. So the bottom row is not going to change. 0, 0, 1, 1. This row, I'm going to add 7 of row 3. Row 2 is going to become row 2 plus 7 row 3. That's going to eliminate here. 0 isn't going to change, 5 isn't going to change. Negative 7 plus 7 is going to be 0. That's what I wanted. Negative 12 plus 7 is negative 5. Now I also have to eliminate it from row 1. To do that, subtract 3 lots of row 3. Row 1 is going to become row 1 minus 3 lots of row 3. The 1 isn't going to change. This one isn't going to change because I'm talking about row 3. This one is 3 minus 3 lots of 1 is 0. That's what I wanted. 7 minus 3 is 4. Okay, I now have zeros above that point. That's what I want. Move up, go to the previous row. I want to start by making this element 1. How am I going to do that? I'm going to take 1/5 of that row. Bottom row is not going to change now. I'm going to make row 2 become 1/5 of row 2. So that's going to go 0, 1, 0, negative 1. and row 1 isn't going to change in this step. If you're really clever, you can, but it leads to mistakes, so do it in a separate step. Okay, I've successfully made the leading entry 1. Now I need to eliminate all the entries above it. So, bottom 2 rows are not going to change. 0, 0, 1, 1, 0, 1, 0, negative 1. And let's eliminate this by putting row 1 to be row 1 plus 2 row 2. Row 1 plus 2 lots of row 2. So 1 isn't going to change. That's going to become 0. 0 isn't going to change. 4 plus 2 lots of this. 4 plus negative 2 is 2. And now I have a solution to my equations. This tells me that for these equations, x must be 2, y must be negative 1, and z must be 1. If you want to, you can check that. Go back to the original equations. Check. Here, 2x plus y minus z equals 2. That's 4 plus negative 1, take away 1, is 2. Correct. And you could check the other two the same. It's probably worth us doing it actually. X minus 2y plus 3z has to equal 7. Let's try. 2 times negative 1 becomes plus 2, plus 3 is indeed 7. And the third equation, 3x plus 5y minus z equals 0. Let's try it. 6 minus 5 minus 1 is indeed 0.